So to explain this table a little bit, this inspector looked at a whole bunch of parts, and some of them ended up being defective. Of the parts that ended up being defective, 5 of them passed his inspection, 24 of them failed his inspection. Of the parts that ended up being non-defective, 208 of them passed his inspection, 9 of them failed his inspection. So find the probability that the defective part passes. How many times did a defective part pass? There were 5 times that a defective part passed. Now, probability is supposed to be the number of outcomes over the total. What's the total number of defective parts? 29. This is where people run into problems. There's a missing column. There should be a column that says total. There were 29 total defective parts. And how many non-defective total? Non-defective, 208 and 9. 217. Okay, so find the probability that a non-defective part passes. How many times did a non-defective part pass? 208 out of a total number of non-defective pieces, 217. So the point of this problem is to remind you that sometimes the information you need won't all be there. You have to remember that probability is the number of something out of the total. And if the total doesn't exist, you might have to do a little bit of work to find the total. Okay, now you all are actually incredibly lucky because you go to a school where there are math teachers. Every time there's an ACT test released, there are math teachers who study that test and find problems on that test and then include them in your notes packets. So 12 and 13 are problems that are very similar to problems that we have seen on ACT tests, and we want to make sure that they don't throw you for a loop. So number 12. There are 5 red marbles, 6 blue marbles, 8 purple marbles, and 7 orange marbles. How many purple marbles must be added so the probability of getting a purple marble is 2/5? Okay? How many purple marbles do we currently have in this bag? 8. And they're saying we're going to add some number of marbles. How many marbles do we currently have total? 26. But if we add X purple marbles, isn't that going to also increase our total? So we also have to do plus X on the bottom. Now once we figure out what this X is, this fraction needs to reduce to 2/5. So this needs to be equal to 2/5. Does anyone remember how you solve an equation that has fraction equals fraction? It's a proportion. You cross multiply. So throw some parentheses around this numerator and this denominator. 5 times the quantity 8 plus X is going to equal 2 times the quantity 26 plus X. And I'm not actually going to finish solving that because I have a feeling that you all know how to solve this equation. Is that a correct assumption? Distribute, get X on one side, numbers on the other. Answer ends up being 4, by the way. So if you're doing this on your own, you want to check. The answer ends up being 4. Add 4 marbles. Number 13 is another very kind of a sneaky problem that I don't want to trip you up if you find it on an ACT test. A bag contains 4 purple, 3 white, and 5 yellow marbles. Jessica will randomly remove 1 marble from the bag, record the color of the marble, and return the marble to the bag. Jessica will complete this process 60 times. How many times should Jessica expect to record that a marble is not purple? Let's look at what we have in the bag. How many marbles do we have in the bag that are not purple? 8 that are not purple. And I'm going to label my work here. So there are 8 not purple marbles. Out of how many total marbles are in the bag? 12 marbles total. I want to set up a proportion, and to figure out what numbers go where, you simply need to match up the information. So it says 12 total. Well, how many times total is Jessica going to do this thing? 60 times. So she's going to pull a marble out 60 times total. And we want to know how many times is she going to get not purple. So that's where your X goes. If you cross multiply and solve, it will tell you how many times she should expect to get a marble that is not purple. So that'd be 12x equals, is that 480? And then you could finish solving it on your own.